As you know, computers are super fast, and so even if it was the case that all they could do is one thing after another in a straight line, as depicted here, they'd still be well worth the time and money that's been invested into them. However, happily, that's not the case. Computers, like humans, have the ability to make decisions based on the context that they're currently operating under. These two diagrams represent what are known as if and if-else statements. And these are the principal ways in which we will make decisions in C and C++ and Java and so forth, the C family of languages. Let's take a look at this first diagram. So this represents an if statement. The basic idea of an if statement is that it gives us the ability to decide whether or not to execute a section of code. So this node here in our diagram represents a decision. And the way that that decision is made is based on some kind of expression that's evaluated. So if the expression evaluates to true, then we're going to execute some set of actions. And if it executes to false, then we won't. We'll skip them. And so unlike the previous diagram we just looked at, where there's a very deterministic sequence of events that happens, in the case of an if statement, this expression gives us the ability to have different behavior under different circumstances. Now, I'll point out that you'll notice that these two edges, the one coming, the false edge or false branch, if you will, coming off of this decision, as well as the one that's true that passes through these then actions, they come back together. So when we're done with the if statement, then the program just continues to execute in a straight line until it hits something else that causes it to branch in a similar way. So an example piece of pseudocode right here just shows us kind of what this would look like in many programming languages. So if is sunny. So this is some kind of, appears to be some kind of variable that has a truth value, true or false. And the expression can be that simple. It can just be a value that is true or false, or it can be more complex. We might be doing some kind of comparison. Regardless, in this case, we're simply saying if it is sunny, then we're going to do some stuff that amounts to playing Frisbee, and then we're going to go on and do the rest of the program. So let's take a look at what this would look like in C++. I can click on the right tab. OK. So here's a very simple program that simply has a single variable, user response, that we will use to record the user's response to the question, is it sunny, Y or N, yes or no? And if the user gives us a Y, then we're going to do this next thing. Now, I'll point out that in C and C++, again, in the C family of languages, when we want to compare two things, we use the comparator or equality operator, which is not a single equal sign, but two. And that's a place where people make mistakes a lot of times. It's really easy to just put one equal sign there. And it turns out that that will compile and the program will run. It just won't do what you expect. So be careful and make sure that you always use equals equals when you're trying to do a comparison. And then all we're doing in this case, looking back at our diagram, the then actions are simply, or is simply, this line which says play Frisbee. So let's run it, make sure this does what we expect, and then we'll talk more about it. OK, is it sunny? So first I'm going to say yes, it is sunny. Play Frisbee. We'll run it again. Is it sunny? And this time, my cursor out of the way there. This time we'll say no. Nothing happened. Why? Well, because we skipped this line of code. So we see that we have the ability to do that now. We can decide whether or not to execute this code depending on, in this case, user input. Now let's get a little bit fancier. Let's say for a moment that instead of just saying play Frisbee, we first decide that we want to celebrate a little bit. So we'll first shout yay in celebration that it is sunny. Okay, let's run this and see what happens. Is it sunny? Yes, it's sunny. Yay, play Frisbee. So that's what we expected. We'll run it again, and this time we'll say no. No, it is not sunny. Play Frisbee. Not what we expected. So what's happening here? Let's look back at our diagram and talk about it. So again, note that the only thing that we're going to skip around in our program when we use this if expression are the then actions. The rest of the program, after the if statement is finished, will execute just in a straight line, again, until we hit something like an if or an if else, as we'll discuss in a moment, but something that diverts it from that straight line. So the question becomes, what are the then actions? And in C, C++, and so forth, the then actions are the very next statement. So we have the keyword if, and then some kind of expression inside of parens, and then the then actions will be the very next statement in our code. And so in this case, that is simply this statement that says yay. So even when we said no, it's not sunny, it skipped over yay and went straight to play Frisbee. The indentation looks nice, but means nothing to the compiler. So even though to us visually this is grouped as one set of actions, to the compiler it isn't. And so we need a way of grouping multiple statements into a single statement that we can then attach to our if. And the way that we'll do that is to create what's known as a block statement. And all that a block statement is a set of statements wrapped around or wrapped by a set of curly braces. So now we've created a block statement that contains these two cout statements. So now the if sees the next statement, or the then actions, if you will, as all of the stuff right here. So let's see if that fixed our little problem. Is it sunny? Make sure it does what we want here. Yay, play Frisbee. So that looks right. Let's run it again. Is it sunny? No, and nothing happened. So that's the basic idea behind an if statement. And we've successfully shown how we can group together statements to have a fancy set of then actions instead of just one statement. Okay, let's look at this diagram now. This is what's known as an if-else. And some of the ideas are the same as in the if. Just as in the if, we have some kind of test expression that will be evaluated. And if it's true, there's a set of then actions that will be performed. However, the way that this differs from our if is that we have a set of else actions that will be executed if the then actions are not. So if this expression is true, we'll do the then actions. If it's false, we'll do the else actions. Okay, and then in either case, the execution of the program will come together, if you will. The possible branches of execution, I should say, come together to indicate that then the program will continue as it did before, just in a straight line again. So here's some pseudocode showing that if it is sunny, play Frisbee, else take a nap. So let's look at this in C++ and look at the syntax for that to get the desired behavior here. Okay, so what we'll do is simply add keyword else, and then I'm going to use curly braces to again attach a block statement to this else. So now if this expression, user response equals y, does not evaluate to true, then the program is going to jump down to this point and execute whatever's inside of these curly braces. Now just like the if, the else looks at the very next statement. And just like with the if I want more than one statement to be executed, I need to put it inside of curly braces. Now, a point to make here, an important point to make, is that though strictly speaking, a single statement does not have to be inside of these curly braces, as we saw a moment ago, just about every organization that has a coding standard is going to require their programmers to put any statement attached to an if else, and so forth inside of curly braces. And that's obviously not for the benefit of the compiler. If it's just a single statement, it could work without them. However, it helps a lot with readability. You'll notice that visually it's very easy to see where the then actions for this if begin and end. And similarly, it will be very easy to see where the else actions associated with the else begin and end. And so for reasons of readability and code maintainability and so forth, you always want to use these curly braces, even if it's not strictly required by the compiler. So let's put in now our set of else actions. And we're just going to say take a nap in this case. And let's see how that does. Is it sunny? Yes, it is. Play Frisbee. That's what we want. So that still works properly. And finally, is it sunny? No. Then take a nap. We'll leave it there. Thanks.